Hello, everyone, and welcome to English Speaking Gym. I am really happy you are here with me today. Today, we are going to train our English while learning something fascinating about science. Our topic today is why time is not the same everywhere. Put on your headphones, relax your shoulders, take a slow breath, and let's begin shadowing together. When I was younger, I thought time was the same everywhere in the universe. 1 second was always 1 second. 1 minute was always 1 minute. And 1 hour was always 1 hour. It felt like time moved in the same way for everyone. But when I learned about modern physics, I discovered something surprising. Time does not always pass at the same speed. In fact, time can move faster or slower depending on where you are and how fast you are moving. This idea comes from the work of Albert Einstein. In the early 20th century, Einstein introduced a theory called relativity. Relativity changed how scientists understand space and time. Before Einstein, people believed that time was absolute. That means it was the same everywhere in the universe. But Einstein showed that time is connected to space. Together, they form something called space-time. Because time and space are connected, time can behave differently under certain conditions. One important factor is speed. When an object moves extremely fast, time slows down for that object. This effect is called time dilation. The faster you move, the slower time passes for you compared to someone who is standing still. Let me explain this with a simple example. Imagine that I am standing on Earth. You are traveling in a spaceship moving close to the speed of light. For me, time moves normally. My clock ticks second by second. But for you inside the spaceship, time moves more slowly. Your clock also ticks normally from your point of view, but when you return to Earth, less time has passed for you than for me. This idea might sound like science fiction, but scientists have tested it many times. Very precise clocks have been placed on fast airplanes and satellites. When those clocks return to Earth, they show slightly less time than clocks that stayed on the ground. This proves that motion can change the passage of time. Another factor that affects time is gravity. Gravity is the force that pulls objects toward each other. According to Einstein's general relativity, gravity can bend space-time. When gravity becomes very strong, it can also slow down time. This effect is called gravitational time dilation. Let me imagine another situation. Suppose I am standing on Earth. You are standing near a very massive object, like a black hole. The gravity near the black hole is extremely strong. Because of that strong gravity, time moves more slowly for you. Your clock ticks more slowly than mine. From your point of view, everything feels normal. But when we compare our clocks later, we see the difference. Scientists have even measured this effect here on Earth. Clocks placed at higher altitudes tick slightly faster than clocks at sea level. This happens because gravity is slightly weaker farther away from Earth's center. The difference is extremely small, but modern instruments can measure it. This effect is not only interesting, it is also very important for modern technology. For example, GPS satellites rely on extremely accurate timing. GPS systems use satellites orbiting the Earth to determine positions. Each satellite carries very precise atomic clocks. These clocks must stay synchronized with clocks on Earth. However, the satellites move very fast as they orbit the planet. Because of their speed, time slows down slightly for them. At the same time, the satellites are farther away from Earth's gravity. Because gravity is weaker there, time moves slightly faster. Engineers must correct for both effects. Without these corrections, GPS systems would quickly become inaccurate. Another interesting idea related to time is the possibility of time travel. Because time can move differently depending on speed and gravity, traveling into the future is actually possible. If someone traveled in a spaceship close to the speed of light and later returned to Earth, they would have aged less than the people who stayed behind. In a way, they would have moved into the future. However, traveling into the past is much more difficult. Scientists still do not know whether it is possible. The laws of physics seem to make backward time travel extremely complicated. When I think about these ideas, I realize how strange and fascinating the universe is. Time feels simple in everyday life. We check our watches, we plan our schedules, we count minutes and hours, but in reality, time is flexible. It can stretch and slow down depending on motion and gravity. Let me explain the main idea clearly. Time is not the same everywhere. If you move very fast, time slows down. If you experience stronger gravity, time also slows down. These effects are usually tiny in everyday life, but in space and near massive objects, they become very important. Understanding these ideas helps scientists explore the universe. It helps engineers design satellites. It also helps us understand the deep connection between space, time, and gravity. The more we learn about time, the more mysterious it becomes. Great shadowing so far. Now let's practice some important vocabulary. I will say each word slowly, I will explain the meaning, and then I will give an example sentence. Please repeat each word with me. Relativity. A scientific theory explaining how space and time behave. Example: Einstein's theory of relativity changed our understanding of time. Space-time. The combination of space and time into one system. Example: gravity can bend space-time. Time dilation. The slowing of time because of speed or gravity. Example: astronauts experience tiny amounts of time dilation. Gravity. The force that pulls objects toward each other. Example: gravity keeps the moon moving around the Earth. Atomic clock. An extremely precise clock used in scientific measurements. Example: GPS satellites use atomic clocks to measure time accurately. Orbit. The curved path an object follows around a planet or star. Example: satellites stay in orbit around the Earth. Now let's practice some useful power phrases. Mind-blowing fact. We use this phrase when something is very surprising. Example, it is a mind-blowing fact that time can slow down. According to. We use this phrase when referring to experts or research. Example, according to Einstein, time and space are connected. In other words, we use this phrase to explain something more simply. Example, in other words, time does not move at the same speed everywhere. This means that we use this phrase to show the result of an idea. Example, this means that astronauts experience time differently. To sum up. We use this phrase when finishing an explanation. Example, to sum up, speed and gravity can change the passage of time. Now repeat these phrases with me one more time. Mind-blowing fact. According to Einstein. In other words, this means that. To sum up. Excellent work. That brings us to the end of today's lesson at English Speaking Gym. I hope you now understand why time is not the same everywhere, and I hope your pronunciation and listening skills are getting stronger. You did a fantastic job shadowing with me today. Remember to practice English every day. Small daily effort creates big improvement over time. Come back again tomorrow for another exciting topic. I will be waiting for you. Thank you. Stay strong and see you soon.